Hi everyone. Uh, we completed the whole uh, chapter of thermodynamics last week, so I'm going to introduce a new term that is very important to the further understanding of the universe and the different processes. Right. So this is entropy. Uh, in the literal meaning of entropy in the dictionary would be chaosness or randomness, but we use the entropy in a different sector. The term we are going to use entropy here it can be used as a randomness. Let me give you an example. Suppose there are, as you all know that matter exists in matter generally exists in three states, that is solid, liquid, and gas. But how do you distinguish entropy in the case of those matter? So I'm going to demonstrate how can you relate entropy with the state of matter and how systems goes from one state to another state, right? Okay. So first, let me give you a mathematical definition of entropy. So entropy is denoted by capital letter S. All right. In some book, S is used for a specific capacity, but now we are introducing entropy as a letter S. Right. Okay. So S is a symbol for entropy, and the formal definition, in fact, mathematical definition for entropy would be dq over T. Let me define these terms for you. Q stands for heat. dQ is a small amount of heat given to the system or heat going out of the system. So it is the change in the heat, right? And T is the thermodynamic temperature. I discussed it with you in the last class, right? So T is in Kelvin, dQ is in joule. So unit for this one would be joule per Kelvin, right? This is a heat, this is energy. Unit for this is joule, and the unit for temperature would be Kelvin. So this is the mathematical definition of entropy. But how do you relate it with states? We are going to learn that. The thing is, we have three different states. First is solid, second is liquid, and third is gas, right? As anyone can guess that when we go from solid to liquid and liquid to gas, a randomness of molecule increases, right? So in physics term or in our term, we say that entropy goes on increasing while we go from solid to gas, right? So in another sense, what I would like to say is the entropy of solid is very small. The entropy of liquid is greater than solid but less than gas, and gas has lot of entropy than solid and liquid. So based on entropy, we can define these things as the entropy of solid is least, and then liquid, and then gas. So let me relate with randomness. The randomness in gas is highest, the randomness in solid is lowest, and the randomness in liquid is in between gas and solid. So entropy, the entropy, the hierarchy of entropy in solid, liquid, and gas goes like this. So now you can make a sense, right? Entropy is randomness. As we go from solid, liquid, gas, entropy goes on increasing. As you go from gas, liquid, and solid, entropy goes on decreasing. So entropy is related with randomness. This is one definition. Okay, everybody understood that? Okay. Let me give you another way to visualize entropy. Strictly speaking, there is no any definition of entropy. I cannot give you a perfect definition, but I can relate with a different sense so that you can make a sense of entropy. Second is, higher the entropy means more strictness, more discipline, right? Solid, gas, and liquid, solid, liquid, and gas are made up of atoms, right? Atoms and molecules. In solid, there is more discipline. The atoms are more disciplined in the way that they can move they cannot move according to their will. But in liquid, they cannot move according to will, but not as in the case of solid. They are less strict than in solid. But in gas, each and every atom can move according to their will wherever they want. So entropy can be related with randomness, and entropy can be related with strictness, right? More discipline. More discipline means more entropy. Less entropy means less entropy means no, sorry. More entropy means less strictness, less discipline, and less entropy means more discipline, more compactness. So you can relate entropy with these things. And the important fact about entropy is what is happening in the universe right now is all because of entropy. All spontaneous process take place in the universe are due to entropy. So this is very important topic, and I will be giving you lecture on entropy. This is the thermodynamic definition of entropy, and next class I will be giving you the definition, statistical definition of entropy. So the things to remember, all in all, entropy is related with chaosness, and entropy is related with strictness, right? So you can relate now. You can, I guess, you can relate entropy with strictness and chaosness. Okay. Anybody have any questions? Then I will answer it right here. Okay, great.